Are we on? Hello, everyone. So this is week number 2, which for JHU Finance begins on January 30th. All the weeks, by the way, are going to begin on a Wednesday throughout the semester. So please look at the syllabus, and every week, week 1, week 2, etc., is on a consecutive Wednesday. There is 1 week of vacation, which I'll alert you to in March, I think. Other than that, the syllabus should be self-explanatory. The lessons are all under the button that says lesson. So just hit that button and you'll see every week's lesson with all the assignments. I have not used the assignment tab because it's redundant, but some of you have asked about that, and if you like, I'll post exactly the same information under assignments. But just go to lessons and you'll see where we should be. So, week 1 was lots of fun. I tried to make it easy on everyone. We certainly learned a lot about what kinds of financial issues that you all have, and there seems to be a recurrent theme of student loans, home loans, car loans sometimes, mortgage issues being underwater, and not yet so much of retirement plans and investing, but that's on your minds. So basically we're going to try to make each week relevant to as many of those things as we possibly can. Now this week we're going to get into it deep right away, and we're going to tackle the most important element of the course in terms of mathematics. Now all of you are science trained and all of you know algebra and probably even remember calculus. You don't need calculus for this, but you do need algebra and a knowledge of scientific notation to understand time value of money, TVM. So here's the textbook right here, and this is chapter 5, and TVM is the key concept which will power your understanding of everything else. So basically, let's make it biologic. If we were talking about bacteria and I asked you about doubling time, you would know right away that that's an exponential function. And that's why those little germs can grow so quickly. And if I asked you about different ways of manipulating the bacterial growth curve, like with antibiotics, for example, you would understand that completely. Well, guess what? This is the same thing, except instead of talking about bacteria, we're talking about how money grows over time. So it's a very, very simple formula which has ramifications for all of those things that are troubling you. For example, here is the formula. The future value equals the present value, parentheses, 1 plus the interest rate to the nth power. And all that means is it's an exponential function which is recursive, because if you borrow money, just like growing bacteria, it tends to double with a certain doubling time. Or in the case of nuclear physics, it has a half-life if you go backwards. So this is how everything is figured out, by applying a recursive formula where you know the present value, you know the interest rate, and you know the number of periods. That's it. That's it. So financial calculators look different from science calculators because they use terms like PMT to equal payment. And that doesn't look the same as it does to a scientist, for example, but it really is the same thing that you're doing when you look at the growth of, let's say, bacteria. So look at these graphs. I think you can see them. Yes, you can. And you can see what happens to the various curves as the interest rate changes. So there's a section here that's all about the difference between compound interest and simple interest. And then when you play with the formula, which I think you should do manually with a piece of paper before you put it in a calculator, when you play with the formula, you will see how small differences in interest rates make a huge difference in the eventual future value of an investment. You will also see what an annuity is and what a perpetuity is. That if you use the formula backwards, you can calculate how much you ought to be getting from a given investment. Same thing is true with a bond. Bond is just a debt instrument with a fixed interest rate and a fixed number of periods. Same thing is true with a mortgage, which is amortized over a fixed period of time. And this is what will convince you, I hope, to learn the following. Interest rates are important, but the duration of an investment is equally or more important than the rate. So for people who chase rates, let's say on a mortgage, it would be much more important to get a shorter term or to pay down the mortgage quickly than it would be to fight really hard for a small difference in rate. Same thing's true of insurance policies. Term policies are usually very effective, cost effective, but as you get into whole life insurance, you're paying a whole lot of money for benefits that you may actually never see. So enjoy this chapter. I suspect there'll be lots of questions when it comes to applying the formula. By the way, if you put any type of financial formula in Excel or any other good spreadsheet, it will do all of this for you. But what I would like you to do is to do just a little bit of it by hand, and I'll give you some examples. Keep checking the website. Thanks a lot.